So today we'll be doing chapter 26, further programming. And learning objectives are this. By the end of this chapter, you should be able to show understanding of what is meant by a programming paradigm. So you'll have to understand these things. Show understanding of the characteristics of a number of programming paradigms. For example, low-level, imperative, object-oriented, declarative. Then write code to define a record structure. Write code to perform file processing operations. Open or close a file. Read or write a record to a file. Also use pseudocode for random file handling. Write code to perform file processing operations on serial, sequential, and random files. We have done this, you remember, no? X file access. Then you have show understanding of an exception and the importance of exception handling. So that's a separate thing, exception handling. When some exception takes place, how are you going to handle it? Like error handling. Show understanding of when it is appropriate to use exception handling. Write code to use exception handling in practical programming. Describe features in editors that benefit programming. Know when to use compilers and interpreters. Describe facilities available in debuggers and how and when they should be deployed. So that's quite big. No? Then the first section 20.01, programming paradigms, difficult to pronounce. A programming paradigm is a fundamental style of programming. Each paradigm will support a different way of thinking, problem solving. Paradigms are supported by programming language features. Some programming languages support more than one paradigm. There are many different paradigms, not mutually exclusive. There are just a few different paradigms. Now we will understand what this new word is. Low-level programming paradigm. The features of low-level programming languages give us the ability to manipulate the contents of memory addresses and registers directly and exploit the architecture of a given processor. So architecture means real hardware, how the processor is made. Architecture of a house is how the house is made and the layout and everything. So same way, when you are using low-level programming, you can really go into that level, the lowest level, where you can really work face to face with the processor. Just imagine, no barriers.
Yes.
We solve problems in a very different way when we use the low-level programming paradigm than if we use a high-level paradigm. See chapter 6 and chapter 28 for programming examples that you can do after this lesson. Note that each different type of processor has its programming language. There are families of processors that are designed with similar architectures and therefore use similar programming languages. For example, the Internet in the Intel processor family present in computers uses the x86 instruction set. So there's another one. Imperative programming involves writing a program as a sequence of explicit steps that are executed by the processor. Most of the programs in this book use imperative programming. Chapters 11 to 15 and chapter 23 to 26. So just you can scan through them when you're free and then see what this means. An imperative program tells the computer how to get a desired result. In contrast to declarative programming, where a program describes what the desired result should be. Note that the procedural programming paradigm belongs to the imperative programming paradigm. There are many imperative programming languages, Pascal, C, and BASIC, to name just a few. So, what comes under imperative programming paradigm? It's a procedural programming. So, the examples are Pascal, C, BASIC. Then comes object-oriented programming paradigm. The object-oriented paradigm is based on objects interacting with one another. These objects are data structures with associated methods. Chapter 27 will give you more details. Many programming languages that were originally imperative have been developed further to support the object-oriented paradigm. Examples include Pascal under the name Delphi or Object Pascal, and Visual Basic, the .NET version being the first fully object-oriented version. Newer languages such as Python and Java were designed to be object-oriented from the beginning. So this paradigm, now I would like you to see the meaning of paradigm. The normal meaning we'll see, then it's easier for you. Pronounce paradigm, say paradigm. Follow that pattern. A typical example or pattern of something, a pattern or model. Real example of pattern. Then a set of linguistic items that form mutually, no, that you can think of this. A typical example of pattern. So like a pattern or like a method. So you have to think of this object-oriented pattern or way or method. Declarative programming method, imperative programming method, or the concept. You can say concept or something like that. And also this, according to this, object-oriented came later, isn't it? Object-oriented came later, and the first one, fully object version, the first fully object-oriented version is the VB.NET. And the new languages, Python and Java from the beginning. The earlier ones, VB didn't start as an object-oriented version because it's when it was about VB4, I remember, 1990s. It was VB4, then quickly it went on to VB5, then 6, and then after VB6 only, this .NET came. But these are new, Python and Java. They were originally like designed to be object-oriented from the beginning. Then the declarative programming paradigm. Declarative programs are expressed as formal logic and computations are deductions from the formal logic statements. Chapter 29. Declarative programming languages include SQL and Prolog. SQL is structured query language and Prolog is a name of a language for programming logic. Prolog. Even for artificial intelligence, it is used, which uses, you declare the rules beforehand, like there are rules and areas. So those things you declare beforehand and then going on logic. That's very interesting. When you have the time, you can study a little bit of that. And 26.02 is records. We use records in chapter 23, section 23.06 onward. To declare nodes, records are used Records are user-defined types discussed in chapter 16, section 16.01. So just recollect those things we did. Remember, there were user-defined types, record types, and composite. Go through that when you're free and then. So here is a worked example of using records. A car manufacturer and seller wants to store details about cars. These details can be stored in a record structure. So type, this is how you declare it. Type and the name of the record, car record. And here you declare vehicle ID. Here is a colon and then string, the type, unique identifier and record key. So we are using the already available types. So string is already available. Date is already available. Integer, currency, these are already available, predefined. But we are going to make them, use them and declare certain things of our own, specialized one, and then have this as a record type, user defined data type. This is a data type. It's a complex one. You have a lot of things here. Composite. To declare a variable of that type, we write declare this car, colon, and car record. That means this car is an object we are making, an instance of this. We are declaring this with this. No, let's say take it this way. When we want to declare a variable called A for say N for number, or yeah, C for counter, we are going to use a variable called C in Pascal, remember? Python, of course, you don't declare. What we do is under var, we put C or count and colon integer and semicolon. Right, that's the way we do count colon and integer, and this is Pascal specific, the semicolon. Same way, when you want to declare a variable called this car, our type, our variable type, this is the type, not integer, car record, our own user defined type. So when you say car record, it will have these things. This whole thing is a data type. Note that we can declare arrays of records. If we want to store the details of 100 cars, we declare an array of type car record. So we can have even 100 cars with this type. All the cars will have the vehicle ID, registration, all these things will be there for each car. Because this is the data type we have defined. Declare car 1 to 100 of car record. This will remind you of how you declare an array. This is important, of car record. Depending on the language, these things can change, but the structure is like this. So here is the first element and the last element, number 100 elements. Then this is the array name. This is the name of the array we are creating. And this is the type of data we are going to have. Normally when we declare, we say A. Array Here we say of instead of integer, car record. That is a difference. And the car record, the type is here. Now integer, you don't have many things like this. Integer is just that it can hold whole numbers, but no place for decimals. It will ignore all the decimals. Here we have more information like the vehicle ID, the registration, date of registration, engine size, purchase price. So all these things are there like a file in a record, and record in a file. And this is in Python, specific things. Python does not have a record type. However, we can use a class definition. Chapter 27 for more details about classes. The pseudocode example of a car record described in worked example 26.01 can be programmed as follows. Class, that's a keyword, class, create a new class. Car record is a name. Declaring a class without other methods. So we are not having any other methods, we are just declaring. Then define, init. These are all specific. This underscore there, the long underscore, and self. That's how you define. Self dot vehicle ID. So self meaning car record, this referring to itself. Self dot vehicle ID equals null or blank. Self registration. What are those? Those are the things here. So with blanks, in this new class, you initialize them for blanks, nulls, and zeros. So the engine size 0, purchase price equal 0.00. These are the values you give at the initial stage, like set initial values. This car equals record, car record. So when you say car record, it's like a function here with two parameters, instantiates a car record. So this record is duplicated, created new with this name. This gets all the details of the record. This car dot engine size. So once you initialize that, and from that, like this self here itself, this self is for this car dot vehicle ID, or that here it's engine size. This car dot engine size equals 2500, assigning a value to a field. So we can address these things, fields. So these are record, like a record. These are fields we can address and apply values or change values to them. This car equals car record instantiates a car record. So that's the same thing like earlier this statement. Then car equals this car for I in range 100. So there are 100 now for I in range 100 means up to 100, 1 to 100. Make a list of 100 car records. And car 1, that's the first element. Engine size, the first car, right? Out of these 100, the first one, first car dot engine size equals 2500, assigning value to a field of the second car in list. Now the VBNet specific thing. Structure car record. That is how that is done. Dim vehicle ID as string. So there is a difference. We didn't have dim there. What did we have? Of course, in Python you don't have that, but in our pseudocode it's declare. But when you come to other languages, you will see a difference. So in VB, In VB, it's structure. So this is a record structure. Car record is a name. And dim, like dimension, like declare. Vehicle ID as string. So this is the type. We had the same, these are the same types that we used in the early example, right? Except currency here. This was currency, the normal one, but here the VB.net, VB.net, it's decimal. So all the things are same. Date of registration as date, engine size as integer. So the word as is a keyword here. And end structure, structure and end structure, like if and end if. Then dimension, dim this car as record. Declare a variable of car record type. So the word as is popular in VB. Dim car 100 as car record. Declare an array of car record type. So here we give only the number 100. Here it was different. Car equals this car for in range 100. But here the car 100 as car record. So that's the way we declare the array here. Then this car dot engine size equal 2500. Same way that we are doing here. This car dot engine size equal 2500. So no difference there. Then car 2 register engine size equal to 1500. Assign value to a field of second car in array. Then finally Pascal. So now you're familiar with this. You say type and end. Like begin and end in Pascal, you say type. Car record equals record. Vehicle ID equals string 20. Registration string 10 with the sizes we give. Date of registration, T, date, time. That's the type, the date, time type. Engine size integer, purchase price, currency. VAR, that is how we, in Pascal, we declare VAR, VAR. This car, colon, car record, and semicolon. Declare a variable of car record type. This is the way they do. Then again another one, car, array 1 to 100 of car record. So of that, this type, this is the type of array and the elements are 1 to 100. Declare an array of car record type. This car dot engine size is the same thing, but except for this colon. The Pascal specific thing, peculiar to Pascal or unique in. This is the colon just in front of the equal sign and the semicolon. These are the two specific things which are different. Otherwise, normally with the dot, you can, with this object, dot, and you get the property. Car 2, yeah, same way here. The second one also, we are changing to 2500, the second car. I think we can't start this now. We should leave this for another day. If we start that, it's too long. Now it's almost, now it's 8 minutes to 12. So we have done 26 point not 2. So next time we'll be doing 26 or 3 or a paper. So we'll decide. You can send me a message or email regarding this. What you like to do, you can discuss with Rugesh also.
Sure, sir.
Want another class? We have at the moment only one. I will leave it up to you. Work it out and ask me for a class. I have so many classes now. Yes, sir. Manu, you want to say something?
Oh, no.
So just go through those things that we mentioned. Some some chapters mentioned, and also you can do the assignments which are there. I will put the recording here under further programming and some assignments also. You can do it and upload here itself. Right then. So thank you very much for joining. We'll see you next week. Bye.
Bye.